How's it, grade 12s? I'm going to be doing exercise 5.9, number 1E with you now. Okay, so the question is, solve the equations correct to 1 decimal place. So we have cos 2 theta plus 2 sine 2 theta minus 1 equals 0. Okay, so when it comes to things like this with your double angles, for example, like this cos here, it can be one of three things from here. Now, I don't know which one to choose, so that's why I leave it. Okay, so I'm going to leave that one for now. The sine double angle, on the other hand, can only be one thing. It can be this 2 sine theta cos theta. And that's what I'm going to expand straight away, is this one over here. Now, just remember that we've got this 2 in the front here. So that 2 and that 2 will give us 4. So I'm going to leave this cos double angle for now, and I'm going to expand this to be 4 sine theta cos theta minus 1 equals 0. Okay, so I've just used our sine double angle. Now, I need to decide what I'm going to make this one of these three things here. Okay, and what's going to help me decide on what to choose is I want to try and get rid of this constant over here, this minus 1. So it doesn't make sense introducing this one, because then we'll still have that. If I introduce this one, we'll get minus 1 is minus 2, and we've got another constant. If I introduce this one, however, that 1 will cancel with that 1. Okay, and then we've gotten rid of that constant. So that's what I'm going to do, is I'm going to expand this one to be this. So we get 1 minus 2 sine squared theta. All right. So what happens now is this 1 and that 1 will cancel, and we're left with minus 2 sine squared theta plus 4 sine theta cos theta equals 0. I'm just going to divide through by minus 2 to make our lives a little bit easier. So divide this by minus 2, we get sine squared theta minus 2 sine theta cos theta equals 0. So what I'm going to do now is I'm going to take out a common factor. And my common factor is sine theta, because we have two terms here. There's our one term, here's our second term, and we have the sine theta is common. So we can take that out, and we are left with sine theta. Over here, we'll be left with a sine theta minus 2. That's been taken out, and we're left with a cos theta equals 0. So what we have now is we have something times something equals 0. So I can set them both equal to 0. So the sine theta is equal to 0, or if I set this equal to 0, I will get sine theta is equal to 2 cos theta. Because if I set it equal to 0, just take this minus 2 cos to the other side, and I get that. Okay, so let's solve for this one first. We need to solve for the theta, so I'm going to be using the general solution. So on your calculator, we're going to go shift sine 0, and that's our reference angle. So the general solution for sine is, it's the one is your reference angle plus K360, and the other one is 180 minus your reference angle. So that's what I'm going to be doing here. So the first one is theta is equal to our reference angle, which is 0 degrees, plus K360, or the other one is theta is equal to 180 minus our reference angle, sorry, it's 0, plus K360. So here we get theta is equal to 180 plus K360. So those are the two solutions here. That's your one solution for it, and that's the other solution for that one. For this one over here, what I'm going to do is I'm going to divide both sides by cos. Okay, Because remember, ultimately what we want to try to do here, grade 12s, is get one trig ratio. So I'm going to use a little trick here. If I divide both sides by cos theta, what I'm left with on this side here is sine theta divided by cos theta is equal to 2. Now we know that sine theta over cos theta is tan theta. So this is tan theta is equal to 2. And now we've got one trig ratio, okay? And I'm going to use the general solution for tan. So we go shift tan 2, and that's our reference angle. So it's going to be theta is equal to 63,4 degrees to 1 decimal. And tan is plus K 180 degrees. Okay. And that is the solution for this one over here. All right. Now, grade 12s, we need to state here that K is an element of the integers. Okay, so that will cover for these two and it'll cover for that one. Please don't forget this. You'll get penalized if you don't put that in. All right. The next one that I'm going to be doing is question F. Okay, again, it's just saying solve the equations correct to 1 decimal place. So question F is 2 sine squared, sorry, I just have to move the cat. 2 sine squared x is equal to cos 2x. Okay, so again, we've got this problem with the cos double angle, okay, and it can be one of these three things. Now, what's going to help me decide what to change it to is what's on this side over here. So on that side, we've got sine squared. And remember, what we want to try and do is try and get it in terms of one trig ratio. So if I introduce this one, then I'm introducing the cos squared. So we'll have a sine squared, a cos squared, and another sine squared. That's not going to help us, okay? If I do this one over here, I'm introducing a cos squared for that. So we've got sine squared and cos squared. Again, two trig ratios, it's not going to help us. If I do this one over here, a sine squared, then I've got a sine squared over here. I've got it in terms of one trig ratio, and that's going to help us. So I'm going to expand it using this one over here, that cos double angle. Okay, so we get 2 sine squared x is equal to 1 minus 2 sine squared x. So I've expanded that to this. I'm going to take everything to the left-hand side, and that will become a plus. So we'll get here 4 sine squared x minus 1 equals 0. Now, grade 12s, what I like to do is I like to use a little substitution where I make coses x and sines y. So here we'll get 4y squared minus 1, because I just make the sign a y. Don't get confused with this x, that's just the angle. Okay, so I just make coses x, sines y, and I get something like this. Now, if I show you something like this, you'll pick it up immediately that this is the difference of two squares. And I can factorize that to be 2y plus 1, 2y minus 1. And that is what I'm going to factorize this one to be like this. So I'm just going to use this, and then instead of y, I'm going to write sine x now. So over here we get 2 sine x plus 1, 2 sine x minus 1 equals to 0. We've got something times something equals 0, so I can set both of these equal to 0 and solve for them. So for this one over here, we'll get sine x is equal to minus a half, or sine x is equal to a half. Now what I'm going to do is just use the trig general solutions for sine to solve for these. So for this one over here, we go shift sine negative a half, and we get our reference angle to be negative 30. So it'll be x is equal to negative 30 plus k 360, or x is equal to 180 minus our reference angle plus K360. X is equal to, that will give us a plus, so we get 210 degrees plus K360. Okay, so that's the solution for this one, is this and this. Let's do the same thing for this one. I need to find my reference angle, so we go shift sine 1/2 and we get a reference angle of 30. So X is equal to 30 degrees plus K360, or X is equal to 180 minus our reference angle plus K360, and we get X is equal to 150 plus K360. And what I need to do now is I just need to say that K is an element of the integers. And these two are the solution for that. Okay, guys, thank you.